far. No, yeah. It's just that he...
1, 4, number 1. What does it mean to change from increasing to decreasing? What does it mean? Maximum. Type it in on a calculator, find the maximum. If that had been a quadratic, then I wouldn't need a calculator because I know how to find the vertex and the parabola. But in a cube, we use our calculator to find the maximum. Yes. Can't hear you. What? Who's asking?
Okay, this is like for the actual exam part, but are all of it just like points, or do the multiple choice or for response, like what does it carry more weight?
It's all points.
Okay.
Okay. And this problem is worth a bunch because it's got lots of parts.
Okay.
Each of the little parts is worth something. 111. 111, number 4, has what third term? We have to remember that the third term of this is going to consist of a coefficient, a power of 2x, and a power of -3. So I need to figure out what my coefficient is. So this is to the 8th power. So you can, let's see, I know, probably this is the quickest thing to do at this point. And I don't even need to do the whole thing, because remember, I'm only interested in the third term, so my coefficient's going to be 28. And then the power on the 2x, if I were writing the whole thing down, 2x would be to the 8th power. Here it's to the 7th, here it's to the 6th power. And that means this one is squared. So I'm going to have 28 times 64 times 9, whatever that is, times x to the 6th. These all get times, the other's going to be some big number, and then I have my x to the 6th still in there. Right? Now the good news is, since I've labeled everything on here, you can go back to those notes and look stuff up, right? I mean, that's the ideal. That's what you should be doing. Olivia?
How do you find the max of a quadratic?
Negative b over 2a.
Negative b over
X equals negative b over 2a.
Okay.
That's the vertex. It's the axis of symmetry, but it gives you the x coordinate of the vertex. All right, what else? Come on, you had a whole period last time to be working with each other and going over stuff.
I just got a question about the triangle. There was a calculator way to do it. Could you show
Not
me?
right now. Yeah. That's probably in your notes. We're looking at what we're doing during office hours.
Will you please do 112 number 2?
112, number 2. So h of x is 3p of 2x minus 1. Okay, I'm only going to find one of those. Which do you want me to find? Does it matter?
No, I didn't.
We'll find h of negative 1, okay? So, and there's no, I don't need, where's p? Oh, p is the table over there, right?
Yeah.
Okay, so I gotta stop and think what this thing does right here. What's happening here? This is going to multiply my y by 3, multiply my function value by 3. This is going to divide my x by 2, and then I'm going to go down 1. All right, now I want h, oh actually I don't even need to worry about all that stuff. I want h of negative 1. So that means negative 1 is x, right? So this is going to be 3p of negative 2 minus 1. So what's p of negative 2? 1. This is 1. So 3 times 1 minus 1 is 2. The answer should be 2. Alex?
For 2.1, number 3, it's neither, right?
I don't know. Did you check the answer?
Oh,
1, 3, 2, oh yeah, that's neither. There's a definite pattern there, but neither, yeah. And what would be your explanation? You're not getting from term to term by adding the same number, and you're not getting from term to term by multiplying the same number. There's no common difference, no common ratio. Right, Sophia?
Can you do number 3 on 2.7?
2.7. Number 3. Says find h of f of x.
We're on this. It's one division. You do negative 3 or positive 3.
So I know find h of f of x, and I know that h is 7x minus 2, and f is 3x minus 5. Alright, so this means I plug this into here, right? F goes into H, so that's going to be 7 radical 3x minus 5 minus 2. So there's the composition. Now, what is the domain? The domain, remember, means if it's under a radical, it has to be positive. So clearly, x has to be bigger than or equal to 5/3. So your domain would be 5/3 to infinity. The range, you didn't ask for it, but remember this part of it's going to be positive, so the range would be bigger than -2 if you were going to do the range.
2.5, 2,
2.5, remember which one?
3. 2,
Pick one.
3.
3. Find an exponential model with regression on the calculator for g of x. So that means I just go to my calculator, go to stat edit, put in those points. So 4, so just 2 points, so 4 and 7 are my x's, and 16.8 and 9.1 are my y's. So then I'm going to go back into stat, over to calc, and do exponential regression. That's what it said, right? Yep. And y equals a times b to the x works out to be 38.048 times 0.815 to the x. So that's all there is to it. You just type it in, let the calculator do it.
What would we do when it says without a regression?
Well, then you have to set up 2 equations and say whatever our points were. So your form is y equals a times b to the x. So one equation would be 16.8 equals a times b to the 4th, and then 9.1 equals a times b to the 7th. I would personally, you can do this different ways, but I would solve for a, set them equal to each other, cross multiply. Delilah? I can't hear you, honey, you need to talk louder.
Number 2 on 1.6.
1.6, number 2, get the end behavior of this function. So we have to look at a couple of things. First of all, we have to look at the degree of the function. And then we have to look at the leading coefficient of the function. So, you said number 2, right?
Yeah.
Okay, so what's the degree of the function? How many x's do I have? 4. So the normal in behavior would be up, up. Here's the problem. If you FOIL all this out, isn't your leading x, your x to the 4th isn't going to be negative? So it's not going to be up, up, it's going to be down, down, which means your end behavior on both sides is negative infinity. Because it's an even degree polynomial. Yeah. And be careful, I said F, it should have been M. That's one of those little things that can cost us if we're not careful.
I have a really good problem, but it's not in the review.
Okay, let's not do it right now, then you can do it during office hours.
Alright.
1.2, number 4.
1.2, number 4. Find the instantaneous rate of change. Okay, so what you need to do, you know how to find the average rate of change, okay? We can't find it at 2, but we can find it if we use if we find the average rate of change on intervals around 2. So maybe find that average rate of change, and then find this average rate of change. Now this is a smaller interval, so going from here to here, we will be getting closer to what it is at 2. And maybe try one more. And you should see a trend here. So this is 3.79, and this is 3.92, and this is 3.99. Well, it looks like we're heading toward 4. Calculus, you have a way of doing that. We don't, so that's how we can do it. You can also, I'm remembering a problem that I don't have any notes for the homework. You could also do like 1.99 to 2, find that average rate of change, and then find 2 to 2.001, that average rate of change, and see what that average is. That would be another strategy, but you're going to need to find average rates of change of something to make it happen.
On 1.5, for question 5, is the best way to find that just to graph it?
Well, wait a second, no, because that could definitely be a no calculator question. How do we find, keep in mind that that's written horizontally, but I could look at that vertically. And notice that my inputs are all evenly spaced, right? So I can make all kinds of conclusions when I look at the differences over here. So that's probably how you should approach it. So that's 2, that's 10, that's 17, and that's 23. All right. That's 8, that's 7, that's 6. That's -1, that's -1. Okay. If these match, it's linear. If these match, it's quadratic. Those match, so it's a cubic.
Would the -1 be the number out in front of the 3 as well? Or is that just the number? Like the -1?
Yeah, I don't know. Why don't you pursue it and see? I don't know. Where's the cubic? You'll do it right now. But, no, I don't know. Maybe. I know that works for slope. I don't know if it works for the other things or not. All right, who else has a question about something? Fred?
Can you do 212, number 4?
212, number 4. Write log x as a vertical dilation, or log base 3 of x equals something times log base 4 of x. That's what it means to be a vertical dilation. So some of you, I noticed in your homework, you kind of notice things, you're putting pieces together, but you're not doing the right, you're not going in the right direction. This says, find the number right here, so that equals a multiple of this. So, there are lots of ways you can always do it. I do it this way. What's that? That is the log of x over the log of 3. What's that? The log of x over the log of 4. So when I multiply, what does all this end up equaling? Log 4 over log 3. And that's what k is. Now, if I have a calculator for this problem, I can absolutely type that in and get a number. That's some decimal thing. And that would be my vertical translation. Or not translation, dilation, my vertical dilation. A vertical translation would be something added to that. Okay? All right, what else? Scout?
1.7, number 3.
Alright, so we got a function. That says, that. And what am I looking for? The end behavior, did I copy it right? The end behavior asymptote. Well, the end behavior asymptote is what we would normally call the horizontal asymptote. But this one doesn't have a horizontal asymptote because that power is bigger than this one. So it has a slant asymptote. And how do we find the slant asymptote? We divide. So we'll put -3 out here and then 3, -7, 1. So what is this? This is my slant asymptote. What's it going to be? Y equals 3x minus 16. Okay?
Can you do number 3 for 1.11?
1.11, number 3. Find all the stuff. Alright, so what's the first thing we have to do? Gotta factor everything. See if anything cancels, get it all factored out. So let's see, in the top I can take out a 2x. And I'll be left with x squared plus 3x minus 4, which is x plus 4 minus 1. Did I factor that correctly? And then on the bottom, I have x minus 1, x minus 1. Right? Step 1, get it factored. Okay, notice we can cancel. So now we have this. And I would like to say, because I canceled, that I have a hole, but I don't, because the hole would have been at x equals 1. But notice, can I put 1 in my problem? No. So I have no holes in this problem, but I have a vertical asymptote at x equals 1. No holes. The only way you can get a hole is to generate a point. And there's no way to generate a point. Does everybody see that? X can't be 1. So, what about a horizontal asymptote? Well, when I look at my problem again, I see that the power on top is bigger again. So there isn't going to be a horizontal asymptote, but there is going to be a slant asymptote. Would you agree with that? And I can find the slant asymptote exactly like I'm erasing here. I'm going to take this numerator, which is 2x squared plus 8x plus 0, and put a 1 out here. Oop, I don't want an x. And divide.
C minus.
So I'm dividing that by this. So it looks like my end behavior asymptote, my slant asymptote, is 2x plus 10. And that is no rules. Oh, zeros. I don't have the zeros yet. The zeros come from right up here. So what are the zeros? 0 and -4. Those are your x-intercepts. Zeros, same thing. Alex?
What does it mean on 2.2, 2, and 3? I just,
2.2, it means that after I got done putting that all together, there were some things I wanted to add in. So after you get done with all the chart stuff, you will see, like, there's graph paper back there.
oh, got it. Thank you.
There's some basic stuff. There are a couple of word problems, all back there at the back.
Thank you.
The addendum is the extra stuff at the end. All right, what else?
2.13, number 6.
2.13,
Like, please don't do the reason.
number 6.
Yeah, well, if you get an A+, I will fight.
All right, so 2.13, number 6. What is wrong with the problem? What's wrong with it? Too many logarithms on the left-hand side. So what's the first thing we're going to have to do?
Move on over.
No, don't move it over, then you have too many on the other side. You gotta put these together. How do they go together? As a multiplication. When logarithms are added, the things you are logging are multiplied. So that's gonna be a big FOIL there. What is that gonna be? 2x squared plus 5x minus 12. Double check that. Okay. And then it becomes an easy problem at that point. Because if the log of my right hand equals the log of my left hand, then what? My right hand has to equal my left hand. So 2x squared plus 5x minus 12 equals 8x plus 2. There will be people who try to do this from the beginning. No, you can't get rid of the logarithms until it's log equals log. Then you can drop them out. So now we've got little quadratic. Looks like it might factor, but it might not. And so either way I can solve it, right? If it doesn't factor, I'll use my quadratic. So I think it does factor. So x equals 7/2, x equals -2. Be real careful though. That one's extraneous, because if you put -2 back into the original problem, this would have you taking the log of -7. Can you take the logarithm of a negative number?
No.
No. Now, again, I think I talked about this before, I'll talk about it again. We're in the habit of, oh, I got a negative number, I'm gonna cross it off. No. You can get a negative answer. If this had been 2x, let's say 2x plus 30, could I put -2 in there? Would that be okay?
Yes.
Could I put -2 in here? Would that be okay?
Yes.
I'll make that a 20. I can put -2 in that one too. So it isn't that the number is negative. That is not the issue. The issue is when you put it back in, it makes this negative. Positive numbers can be extraneous too. If this had been x minus 4, could I put in 3.5? No. So this doesn't matter. It's what happens when you put it back in. All right? One more, quickly, we got time for one more if it's a fast one.
On 1.2, oh wait, no, 1 point, for table 2, is that
For the,
quadratic because the
Why don't you try
x's
it
are
at
going,
home?
like, you multiply,
not perfect.
or exponential?
Okay, now, be careful. Table 2, what is happening to your x's? Your x's are being times. That's a multiplication over there. What's happening to your y's? They're an addition. What kind of function is it that has the x's? That's a log function. That's a log function. It is neither linear nor quadratic. We didn't know about logs back then, now we do. So, it is a logarithm.
Double dog day,
You see?